Okay, here's warm-up 11.1. We're going to find the sum of the measures of the interior angles of a regular heptagon. So first thing, we need to know how many sides a heptagon has, and it's going to have seven sides. Okay, so the sum formula for the interior angles of a polygon, it doesn't actually matter if it's regular or not, is going to be n minus 2 times 180 degrees. Okay. So n is the number of sides, so I just need to plug in a 7 here. And then I've got 5 times 180 degrees. So that's going to come out to 900 degrees. That's the sum of the interior angles then. Okay? All right, the sum of the measures of the interior angles of a convex polygon is 3060 degrees. We're going to classify the polygon. So we're going to use this same formula because we're talking about the sum of the interior angles again. So the sum of the interior angles is going to be n minus 2 times 180. The difference here, though, we have the sum. We don't know the number of sides. I need to figure out the number of sides in order to classify this. So I'm going to plug 3060 in right here. Okay, and you could, now I need to solve this for n, so you could definitely distribute the 180. I think a lot of people would do that, and nothing wrong with that. I'm going to just divide the whole equation by 180, though, because those will just cancel, and then I'll just have n minus 2 on the right side. So let's see, 3060 divided by 180 gives me 17. And then I just need to add 2 to both sides. All right, and then I've got n is 19, so that's the number of sides. So classifying this polygon, it's a 19-sided polygon. I don't have a special name for that. I'm sure there is one, but I don't know it. So I'm going to call that one a 19gon. If it's not one of the common ones, I just use the number. Okay. All right, on to the next problem. We want to find the value of x so that these two segments are parallel. Let me add that in. Okay, so what I like to do on these is just pretend they're parallel and then solve for x. So if those were parallel, then these segments would be in proportion. So 16 should be to x minus 2 as 14 is to x minus 3. They're going to be in proportion. So yeah, let's set up a proportion. 16 is to x minus 2 as 14 is to x minus 3. There's lots of different versions of this proportion that will work. We're going to cross multiply to solve this. So if you set up a different proportion, as long as the x minus 2 and the 14 are diagonal from each other, you'll wind up with the same cross products. Okay, so all right, so let's cross multiply here to get rid of the fractions. 14 times the quantity x minus 2, make sure you use parentheses there because we're going to distribute that 14. Same thing on the other diagonal. Okay, so I've got 14x minus 28 and 16x minus 48. Okay, now I want to combine like terms, so I want to get these x terms on the same side. Let's subtract 14x from both sides. Give myself enough space here. Okay, those canceled there, right? Okay, and I'm going to add 48 to both sides to isolate the 2x. And divide by 2. Okay, so when x equals 10, then those sides would be in proportion, and that means that those line segments would be parallel. Okay. All right. This next problem, sorry for my sniffling, I got allergies here. Okay, so I've got these two congruent angles. These are supposed to mean that those are congruent, so I like to kind of mark them like that, but the book always does it with just the swooshes. Okay, so we can set up a proportion here as well. So 11 is going to be to that piece as 14 is to this piece, okay? The thing is, I don't, some people will say, oh, 11 is to 20 is 14 is to x, but 20 is not the measure that little pink piece there, okay? So I need to come up with a name for this piece. So here's what I can do. That whole segment up here is 20, the right piece is x, so if I take the whole thing minus the right piece, that would leave me with the left piece, right? So the whole thing is 20, the right piece is x, so if I take 20, subtract the x out, then I got 20 minus x here. A lot of times I see people write x minus 20, but that wouldn't make sense. X is smaller than 20, right? So I need that would leave me with a negative segment length. Okay, so now I can set up a proportion. 11 is to 20 minus x, as 14 is to x. And again, there's lots of different versions. As long as the 11 and the x end up on a diagonal, then you'll have the same cross products, and that means that proportion will work in the same way. Okay, so 11x here is going to equal 14 times the quantity, 20 minus x. Okay, I'm going to distribute the 14 to get rid of the parentheses over here. Okay, let's add 14x. And then divide by 25. And that's going to come out to 11.2. All right, that is the end of the warm-up, and I'll see you next time.